thank you. I hope everyone can see my screen. So today I'm just going to talk about my project, which is Picta, a graphing library for the Scala programming language. So I have the agenda here, but I'll really just leave it for reference because I think the flow of the slides is quite self-explanatory. And first, I will talk about the general problem with the Scala graphing ecosystem, which is why this project was, I guess, created. So in general, existing graphing libraries have failed to keep up with developments in the Scala ecosystem. And this claim really has, I guess, three premises, which I'll outline now. One, Scala has become quite well suited to big data analysis or data analysis in general. And that's because of frameworks that are written specifically for it or in it. And some examples are Spark, Kafka, Samza, and Flink. And the second premise is that visualization is important. So we have all this big data, but we should have a good way of visualizing and interacting with it because that can actually generate insights. And then I guess the third premise is that, unfortunately, from the reviews that I've done, existing libraries for Scala have not been well suited for exploratory visual analysis. And typically they lack Jupyter integration, so you can't use them inside notebooks. They're hard to use and require a lot of boilerplate, so you end up becoming essentially a programmer instead of a data analyst or a scientist. And a lot of the libraries lack functionality. So they don't have a complete suite of plots that you can actually make for your data. And the end result of all of this has been that people using, I guess, Scala generally offload their visualization tasks to other libraries, such as Python's matplotlib, which is not a good result. So this project was created to, I guess, offer a solution to this gap in the Scala ecosystem, and the library itself is called Picta. So what is Picta? So Picta is a graphing library that's essentially designed to overcome these shortcomings. So originally it was envisioned as a visualization package for Conus, which is a concurrent forward modeling library written by Dr. Cedric John at the Carbonate Research Lab at Imperial. And really Conus makes it very efficient and easy to create large-scale forward models. But as the project was being written, I guess there essentially became an understanding that we could actually create a standalone library which could actually tackle a lot of the problems that exist in the Scala ecosystem elsewhere too. And really, Picta uses a bunch of open source libraries for its functionality. So I have an architecture diagram. I won't delve too much into it because I think it's quite nice to just read on its own. But essentially, Picta uses a bunch of libraries to create a JSON schema, which is then rendered using plotly.js, which is a JavaScript library which allows rendering in the internet browser. And so Picta allows you to render plots in a Jupyter notebook or a browser. I guess is the essential takeaway from this diagram. And really, Picta uses a bunch of features of Scala to meet its aims, which I'll outline now. So one is to create an interactive graphing library suitable for EVA, which was mentioned earlier. And this is possible because Picta is fully integrated with the Omen Jupyter kernel, which is a Scala kernel for creating, I guess, Scala-based Jupyter notebooks. It's also designed to be very simple. So the key, I guess, design aim at the beginning was to keep everything as boilerplate free as possible. And there's a bunch of Scala-specific features which allow this to happen. So infix operators, the type system, immutability, all of these come together to define basically a domain-specific language, which makes it very easy to compose plots. It also has a lot of functionality, and the reason why this was possible in a 3-month time frame was because of functional programming and object-oriented techniques, which allowed extensible and modular code to be created. And finally, the library also allows Conus models to be visualized in a very straightforward manner. So those were the aims. I'll now just, I guess, show a few examples of the library in action, because I think this is quite an interesting place to focus on. So as mentioned earlier, the library can be imported very easily into a Jupyter notebook using these two, I guess, cells, and then basically have the whole power of Picta at your disposal. Creating simple plots is very easy. So you can see that this cell essentially does all of this difficult work for the user, and it creates this scatter diagram, which is fully interactive. It can be interacted with. You can pinpoint specific data points, and that's really the power of Plotly.js, which is why we use this library as a basis for Picta. Creating more complex plots is very easy. You just essentially layer on more components. So here I create a slightly more complex plot, which has multiple axes at the top, and it also has multiple series. And essentially what this chart creates is a 2D density chart. So basically this pretty cool looking plot on the screen. And in general, a lot of existing libraries find it quite difficult to create such a complex plot because we have multiple axes. We have something going on in the middle, and we have color bar. But really, using Picta, it's very simple and it's very logical. So you create the axes, you create the series, and then at the end, in the chart object, you accumulate them. And again, it's very straightforward compared to existing solutions that are out there. And then finally, just to highlight some more of the functionality of the library, this is not an exhaustive list, but just to show that it can create a wide variety of plots which are interactive. We have, pie charts, we have split axes, we have multiple axes for the same x-axis or the y-axis. We can do both. Contour plots, heat maps. One interesting chart that I find quite cool is the surface plot seen here on the left. That's completely interactive. So you can imagine that if you're modeling some kind of scientific process, having the ability to visualize it over time can be quite useful. And we can actually do that in the library. We have maps, we have 3D line charts. We can have IO functions which pull in from Excel, which is what this iris dataset does here. We have a whole variety of plots, and then at the end we also have these animated plots. So you can sort of imagine this is a sort of gas or something, for scientific purposes, and we can model the evolution of that over time, frame by frame, in quite a simple manner. And so that's just a quick overview of the variety or the scale of the functionality in the library. And then finally, I want to focus on the Conus integration. So Conus was the forward modeling library, and we can easily plot, forward models in a Jupyter notebook or in the browser. So here I plot a example that's available in the repo, which models basically the evolution of rats or a rat population over time. So you can see how the two variables evolve over time, and you can also create a surface, which is what Conus is pretty handy for, and visualize a bunch of different data points in 3 dimensions. And so I guess that leads us on to what's next, or an overview or a critical discussion of the project itself, which is what I'll do now. So really, I see in terms of future development, there's quite a few avenues that can be explored. One is we can add a lot more functionality. So once the Conus API stabilizes, we can add a few more functions that interact with the library there. Or we can also add, I guess, more charting functionality in general. So for example, ternary plots, we don't have that at the moment, but that can be easily included into the library at a future date. Spark integration is another one. So Spark is a distributed data library, and we can use potentially Spark SQL to wrangle the distributed data sets and visualize them in a simple and easy way. And then finally, moving to a slightly different library for rendering. So Plotly.js is actually based on d3.js, which is a lower level library. And moving to that could actually be pretty useful because it will allow us to make the project a bit more independent and a bit more flexible going forward. And then, so to finally conclude, I think Picta makes an original contribution to the ecosystem because it achieves essentially all the project aims that were set out at the start. It has extensive functionality and it's suitable for exploratory visual analysis, and it integrates with Conus. So really, I think it provides a way to create a very vast variety of plots in a very simple manner, which I think is missing from the Scala or the Java ecosystem today. So thank you for listening. I'll open up for some Q&A now. So that's pretty much the stuff I wanted to talk about. So if you have any questions.
Okay, great. Thank you for that. It was a